Once again, you're welcome to our online teaching series. Today we are going to take a look at a very simple problem in chemistry that we diagram distinguish between electrovalent and covalent bonding. Now, electrovalent and covalent bonding. Now, in chemistry, atoms of the periodic table go into chemical reaction because they want to be stable. Elements of the periodic table, those ones in group 8, we have a special group of elements in group 8, they are called the noble gases. Those noble gases have a characteristics, we call it the duplet or octet configuration. They have a configuration that their outermost shell is completely filled. And because of that completely filled outermost duplet or octet configuration, you find out that the group 8 elements rarely go into chemical reaction because of their stability. That stable structure is very, very difficult to disturb. Every other element of the periodic table want to be like the noble gases. And the only way they can acquire that stable structure is when they go into chemical combination. Now, in chemical combination, two elements, probably A and B, will combine. When they combine, I want us to understand that initially, before they combine, there is a chemical bond. But as they are about to combine, the bond inside of them will be destroyed. So we say that in chemical combination, before reaction, old bond has to be destroyed and new bond has to be created. If A and B react, the bond in them has to be destroyed to form C and D, new bond. So we are going to take a look at a typical example of electrovalent bonding. In electrovalent bonding, also called ionic bonding. Why is it called ionic bonding? It is called ionic bonding because ions has to be formed first. How ion forms? We know that when atom loses an electron, it forms a positive ion. When an atom gains an electron, it forms a negative ion. Now, this positive and negative ion will not combine to form the electrovalent compound. Let's take a good example, the formation of sodium chloride. Now, in the formation of sodium chloride, here we have sodium reacting with chlorines, a gas. It forms sodium chloride, NaCl. Let us analyze this reaction. Sodium has an electronic configuration of 1s2, 2x2, 2p6, 3x1, plus chlorine atomic number 17, 1x2, 2x2, 2p6, 3x2, and 3p7, 5 rather, atomic number 17. Now, if we take a look at what we have here, here 1 means the first shell, 2 means the second shell, and 3 the third shell. Here we have the first shell, second shell, and third shell. So if you take a look at what we have here now, you find out that sodium, electronic configuration of sodium, first shell takes 1x2, 2 electrons. Second shell, 2x2, 2p2. If you add it, 8. So the second shell takes 8 electrons. 8 electrons in the second shell. And when we got to the third shell just have 3x1, 1. Now this reacting with chlorine. First shell, 2 electrons, 1s2. Second shell, 8 electrons, 2x2, 2p6, 8 electrons. We have 8 electrons here. And we have the third shell, 3s2. If you add the superscript together, it gives you 7. Now this is what we have. This is chlorine. Now in this reaction, if you take a look at chlorine has 7 electrons in its outermost shell. 1, 2, 3, 4, 5, 6. It wants to make its outermost shell complete, 8, to be like the noble gases. Sodium also, now take a look at it. It has just 1 electron. It is very, very difficult for sodium to attract 7 electrons. As a matter of fact, it's a metal. So during the reaction, there will be a transfer, a donation of electron from the sodium atom to the chlorine atom. So let's say this is the electron. So you find out that this electron is gone. Take a look at it. That electron is gone, leaving sodium with its atom shell 8. But remember, sodium, because it has lost 1 electron, it now forms Na+. Na+ meaning it has lost 1 electron. Now here, sodium has accepted the electron. Take a look at it. The electron has been accepted. Now, this will now make chlorine to have additional one electron. That additional one electron that has come in will make chlorine to form Cl minus. So you see that unlike charges will now attract. When these unlike charges attract now, it now forms NaCl, sodium chloride. So you can see that in the formation of sodium chloride, with the typical example of an electrovalent compound, you find that there was actually a transfer of electron from one atom and a recipient of an electron from another atom. So we should have an understanding that in electrovalent bonding, there is a principle of donation and recipient. Donation and recipient principle. One donate, the other one receive. Now let's quickly take a look at covalent combination. In the covalent bonding, in covalent bonding, you find out that there is no transfer of electron from one to the other. Rather, the two reactants come together and donate equal amount of electron to be shared. They donate equal amount of electron to be shared, thereby obtaining what we call that octet configuration. Let us take, for example, take a look at the formation of water molecule. Formation of water. Now, formation of water. Formation of water is a good example of a covalent combination. Now, water is H2O, which will have two atoms of hydrogen and an atom of oxygen. So oxygen now. So I have my oxygen, H2 plus my oxygen. This goes to form H2O. In this reaction now, what happened? Let's do two atoms of hydrogen. So now what happens here? Hydrogen has atomic number of 1. Now, but you can see that in the formation of water molecule, we have two atoms of hydrogen. So let's say here I have hydrogen, and hydrogen has only one electron. Here I also have another hydrogen, one electron, reacting with oxygen. Oxygen has atomic number of 8. The first shell takes 2 electrons, and the second shell now takes 6 electrons. 1, 2, 3, 4, 5, and 6. Now, during the reaction, you find out that what we have here is that the oxygen molecule here now needs 2 electrons to make it atom shell complete. While each of the oxygen atom need 1 to make their atom, since it's the first shell and the first shell can carry only 2 electrons. So in the reaction, this is what happened. This is before they combine, before the combination. Now, after they combine, after the combination, they come to form something like this. Take a look at the oxygen atom. There is the oxygen, first shell 2, second shell here 6, 1 here, 1 here, here 2, here 2. Now, each of these oxygen hydrogen atom now comes with a single electron. Look at it. This one comes with a single electron here to be shared. This one comes with a single electron here to be shared. So by so doing, this hydrogen comes with a single electron here, and they now share. This other hydrogen also donate this one electron here with the oxygen, and they both share. By so doing, what we have here now is a molecule of water, H2O. And if you take a look at it, the oxygen atom now is having 1, 2, 3, 4, 5, 6, 7, 8. And each of the hydrogen is having 1, 2, 1, 2. This kind of combination where they shared is called a covalent combination. So, in a nutshell, in electrovalent combination, there is a transfer of electron from one atom, usually a metal, to another atom, usually a non-metal. And in the covalent combination, that transfer is not there. Rather, the reactant, the two reactants, donate equal amount of electron to be shared. That is covalent combination. So I believe this little illustration and explanation have done justice to the question we have on the board. In our next class, in our next series, we'll see more of chemical combination. Thank you very much, and bye for now. We will see in our next episode. Bye.